In this video, we are going to be using areas to solve our integrals. So first things first, what you have to notice on this one is that you always have a number or a function on this side. So what type of a function is this one? You see that this one, it's a linear function. Then if it's a linear function and you want to solve this using your Cartesian plane, how is this going to look like? You will have your Cartesian plane, which looks like this. But now, what numbers are we going to use? We're actually given a restriction, which is this number that you see here, your 1 and 3. Normally, we denote this one by A, then this one would be your B. That will be when you are doing what we call it's your Riemann's rule, or you are trying to calculate the exact value. So in this instance, we're just going to be using the numbers as our restriction that we're going to be working on our x values, that is between 1 and 3. So how is that going to look like? We have our 1 here, we have our 2 here, we have our 3 here. And this being a linear function, you check what type of slope does it have. It has a positive slope. It means it's going to be going up. Then now we check that, okay, since we have our function 2t, we go and input the x values into this function. So if we input 1, what are we going to have? We're going to have 2 multiplied by 1. It's going to give us 2. So let me just write 2, 4, 6, 8. Then, okay, if I input, remember, we're having our region between 1 to 3, we'll have 1, 2, 2, 3. So we start with 1. 2 multiplied by 1 give us 2. So we're going to put the first number here. Then 2 multiplied by 2, this will give us 4. So we're going to write that one. So 2 multiplied by 3, this gives us 6. So we're going to write that one there. Then now you see this is the type of slope that we're going to have. But remember now, we're having what? We're having a line that looks like this, but still that doesn't help us solve our problem. So what you're going to do is that you're going to draw your dotted lines going down, and see if you can use that particular shape to solve your problem. You see now we have this kind of shape. I don't even know shapes that well, but we can't work it out. But you see or realize that if we were able to cut this one here, we would actually be able to work them out, because we are going to be having a square at the bottom and a triangle at the top. So let me just do it like this. We have this one and the one at the top. So we'll see we have what? We have a rectangle that looks like this at the top. Then we also have our square at the bottom. Then we'll ask ourselves, what is the area for this one? Area is equals to your half base times your height. Then your area for this one, it's your length times your breadth. So let's start with the more easier one, which is this one. Then you ask yourself, what is the length? The length is between here to here. Then that would be your 2. How do I get my 2? Because a lot of people make a mistake of using your 3, because you're basically from here, you'll say you have 1, 2, or to be safe, always subtract this number that is on your right to your left hand side. Your 3 minus 1 will give you your 2. Then your breadth, it's definitely from here going up, which is going to be 2. Then this will give you 4. Then on this one, you will say you have half of base. What is your base? Your base, we just explained it that okay, it's this one here, which is going to be your 2 multiplied by your height. So your height, we are trying to work out which height. It's going to be the height of the triangle itself. So it's going to be the height that is from here to there. You see? So that will definitely be the height. So if we want to work out that height, we have this height. We will say our height will be equals to, we have the height from here to here, which is 6. We'll have 6. Then we deduct this small one, which is, remember here, I can say I have 2. Then here it will definitely mean I have 4. Then it will basically 6 minus 2, and it gives me that 4 that I have. So now you will see you have 4 here. Then half of this is basically your 1 times 4. Then this gives you your final answer of 4, and also this side it gives you your 4. So you will say you have your total area. Then it will be for the triangle plus for the square. Then this will be the same as having your 4 plus 4. Then this will give you your 8. So that's basically how you use your Cartesian plane to solve that one. So now let's pretend if we're going to use the antiderivative, so that you can see that you can definitely get the same answer for this type of question. So you definitely have a backup method that you can use to verify that you're still on the right track. Remember, we have an integral that is between 1 and 3. We have 2t dt. Then the first rule is that okay, we can actually try and take this 2 to the other side. How will this look? You will have your 2, the region between 1 and 3, then you have your t. But we do know this can be interpreted as the same as having your t to the exponent 1. Then what happens if we have our 2, we have that criteria to the exponent? We can actually use what? We can use the power rule. So what does the power rule say? The power rule says if you have an integral of x to the exponent n, you can write this one as actually as your 1n plus 1 multiplied by your x to the exponent n plus 1. So in this instance, what is our n? Our n will actually be this 1 that you see here. So it means if I'm about to take this t here, what will I have? I will have my 1 over 1 plus 1, the 1 for the n. Then here I'm going to multiply by the t. Then here I'm going to have 1 plus 1. What will this give me? This will give me 1 over 2 multiplied by t to the exponent 2. So the final answer for this one, it will be t squared over 2. So let's input this one back this side. What are we going to have? This is the same as having a 2. Then we have this. Then we're going to say we have t squared over 2. It will look something like this. But now, what are we doing? We are actually going to say we're bringing this one back again. We'll say we have our t squared over 2 multiplied by the 2. So the 2 will cancel each other. Then we'll only be left with t squared. And still we're not done. So with our t squared, we have to work this one between which region? Between 3 and 1 is given. And you will see that where we see our t, we input 3 and 1. We will say what are we having? We have our 3 squared minus our 1 squared. This would be equals to your 9 minus 1, which is going to give us a value of 8. And what do you notice? We have what? We had 8 when we were using the Cartesian plane, and we have 8 this side when we were using our antiderivative. So yeah, that's basically how you can also try and see if you're still doing the correct calculations. So the last one that they would ask you, let me erase this one. So instead of having a function like your linear, I think I've also seen one where they say something like okay, they said use areas to find what? Okay, they give you an integral that is between was it 2 and minus 5? Yeah, it is 2 and minus 5. 2 minus 5. Then they give you 2 here, and they said you have your d of x. So if we are going to solve this one using a Cartesian plane, how is it going to look like? Remember, we still have the criteria, or the restriction is going to be between minus 5 and 2. So you have that minus 1, minus 2, minus 3, minus 4, then we're going to have that minus 5 here. Then the 2 here, it will just be your y value. So you're just going to come and indicate it here. This will basically be your y is equals to 2. Then and now, okay, they said it's between minus 5 and minus 2. This side you have your 1, and here you have your 2. You do your markings here, minus 5 and minus 1. Then okay, you draw your dotted lines to that one and to that one. So now what do you have? You have a shape that looks like that. And we said the area for this one, it's your what? It's your length times your breadth. See? So what would be your length? So your length is basically from this side to this side. I said if it sometimes confuses you, you can also deduct. You'll say 2 deduct the one that's. So with this one, you're going to say you have 2 minus into minus 5. This will give you 2 plus 5, which is going to be 7. See? So another way that you can confirm, you start counting from this side going that side. You have 1, 2, 3, 4, 5, 6, 7. See? Then you have your 7 multiplied by the breadth, then going up, it's basically your 2. Then this gives you your 14, because the distance from here to there, it's your 2. You can even throw it nicely like that. So that's the one that you're going to be having. So that's basically it on areas to solve your integrals. So sometimes they will just give you a function, or they will just like they give you in a single term like that one, that would definitely indicate that okay, that would be your y value. So I'll see you guys on the next video.